So here we have a problem. One kind of cake requires 200 gram of flour and 25 gram of fat, and another kind of cake requires 100 gram of flour and 50 gram of fat. So now you have to find the maximum number of cakes which can be made from 5 kg of flour and 1 kg of fat, assuming that there is no shortage of the other ingredients used in making the cake. So we have to solve this problem with LPP graphically. So now, first here we'll take let Bx cakes are of first kind. There are two kinds of cake, and Y cakes are of second kind. Now we'll reduce this problem in equation form. So here I've taken a table. In the first column I have taken cake of kind, like we have X number of cakes for first kind and Y number of cake for the second kind. Now according to question, it is given one kind of cake requires 200 grams of flour. So 200 grams of flour is needed by the first cake and 25 gram of fat is needed. Now other kind of cake requires 100 gram of flour and 50 grams of fat. Now we have to maximize the number of cake. So we have to maximize number of cake. So how many cakes will be there? Total X plus Y cake. So that will be our one of the problems. So we have to maximize, also that will give you the Z. So Z is equals to X plus Y. So we have to find maximum Z. So this problem is to maximize Z equals to X plus Y. Now here we have this equation. Now in the question it is given that there are total flour is 5 kg. So 5 kg. Now like this thing is in gram, here fat is also in gram. So I'll convert this 5 kg in grams. So it will be 5,000. And then the fat is 1 kg total fat. So it will be 1000 kg. Now we will make the equations from this. So here you can see, first we will make an equation from this one. So here we can write this first constraint as 200x plus 100y, and this value can be less than or equals to 5000, because we can't take more than 5000, but we can take less than 5000 also, no worries. And then the second constraint we will get from 25x plus 50y less than equals to 1000. So these will be two constraint, and also this we will get that x and y both will be greater to 0. So from this problem you can say that the given problem is to maximize z equals to x plus y, which is subject to constraint 2x plus y less than equals to 50 and x plus 2y less than equals to 40. I've just reduced these equations, and also where x and y both are greater or equals to 0. So now as we will draw the graph for these. So here we can say we have this first, this is our second equation. So we'll make a graph for this. So first I'm making for our first equation, that is 2x plus y less than equals to 50. So here we will get x by 25 plus y by 50 less than equals to 1. So here x is 25. I'm making roughly so you can make it. So here this point is 25, 0 and the other point is 0, 50. So this we will get here, and I'll just write the equation also. 2x plus y is less than equals to 50. So this will be our first equation. Now I will make it for the second equation. So second I'm writing x by 40 plus y by 20 is less than equals to 1. So x is 40, so it will be somewhere here, 40, 0, and then 20 somewhere here, so 0, 20. So this I have drawn like this. So now we have to find out this thing, this point also. Now you can see the common of this is below the line, so the common of this visible region will be this region, and then we'll find out this common point, intersecting point of these two. So this point will come 20, 10. After solving the first two equations 1 and 2, you will get 20, 10. So this will be the point. Now after getting the visible region, you have to find out the corner point. So we already have the corner point. Now we will make the table for this. Now let's label these points. Let's say this is A, this is B, and this point is C. This you can take, this is D. So first I'm taking A. A is 20, 10, and then B is 0, 20. C is 25, 0. And then if you want, you can take C also, but here you know that you will get only 0. So let's take D also 0, 0. So now we have to find out Z and these values. So x plus y will be 20. Here also 20 plus 10, so that will be 30. Here we will get 20, 0 plus 20 is 20, and here we'll get 25, and here we'll get 0 only. Now the problem is to maximize. So we have to find out maximum Z. So the problem was to maximize. So here we have to find out the maximum value. So here you can see which one value is the maximum. 30 is the maximum value, and we are getting this at point A, that is 20, 10. So here we can say thus maximum number of maximum cakes that can be made will be 30. So 30 cakes can be made maximum, and in such a way that 20 will be of first kind and 10 will be for the second kind. So like this you can do these kind of word problems.